Now you recall learning about the wrapper classes, and in particular the wrapper classes that were numeric, and also big integer and big decimal. So considering the numeric wrapper classes and the big integer and big decimal, these are all derivatives. In other words, they're all subclasses of a class called number. And it turns out that number is an abstract class. You will also recall that all of these classes, that is the wrapper classes and the big integer, big decimal, all had conversion methods: byte value, short value, int value, long value, float value, and double value, for returning appropriate primitives of those particular types from wrapped objects. So a point to consider here is that these methods are defined inside the number class, but they're defined as abstract because within the number class we don't know exactly what kind of primitives or wrapped primitives we're dealing with. It's a more generic, more general class. It's a parent class of the wrapper classes, and therefore we can't pin down what those particular methods are going to look like, but we can still have abstract versions of them as placeholders within that abstract class that we call number. This diagram nicely sums up what we just finished talking about. We have the abstract class number, which has placeholders or abstract equivalents for all of these conversion factors: byte value, short value, and so on, all the way down to double value. Those are all defined to be abstract functions within the abstract class number. However, the number class then is extended to all of the numeric wrappers: double, float, long, integer, short, and byte, as well as to big integer and big decimal. And inside of each of those classes in turn, we will have specific implementations of each of those conversion methods that you see above. We're now going to explore the abstract class number in the context of a method that we're going to design to determine the largest of a number of different numbers that we've been passed. It's interesting that in this example we're going to be able to build a list out of different kinds of wrapped primitives. So in other words, we're going to have integers and doubles and big integers and big decimals and put them all together in a list, and then go through the list and figure out which is the biggest one. This is going to wind up revisiting a number of different things we've looked at throughout the course so far. First of all, we're going to start by revisiting the array list that we studied not long ago. So notice that we are declaring an array list using the generic type number in this case. So number is actually an abstract class. We're going to call this list, and we're going to set it equal to new array list number. And even though number is abstract, we're allowed to do this because it's like sort of an array that we did earlier, where you saw a few slides ago, even though geometric object was abstract, we could still create an array of it. Similarly, even though number is an abstract class, we can still create an array list of number. Moving on, the first thing we do is we add to this newly created empty list the integer 45. Notice that we've provided a primitive as an argument, but we're going to get that auto boxing feature where the compiler is going to know that 45 is a primitive. It isn't a number from the abstract class number, so instead it's going to automatically box it up for us. It's going to wrap it in an integer wrapper, and it's now going to be an object, and it's going to go into our list that way instead of as the primitive integer 45. Similarly, even though in the next line of code we do list.add and we've provided a double, which is also a primitive, we're going to have that auto boxing feature that's going to wrap it up as a wrapped double object, and it's going to go into the list that way. This auto boxing doesn't happen in the next two lines because in fact big integer and big decimal are objects already, but we are passing strings to represent a very big integer in the one case and a double of 2.090909, etc. Notice the number of decimal places present in that double are probably going to exceed what an actual double would be able to hold. But that's allowed because this is not a normal double, it's a big decimal. So we can have an arbitrary number of decimals past the decimal point because of that. To finish this off, we print a message that says the largest number is, and then we print the returned result from get largest number, passing it our list. We haven't seen that implementation yet, but that's going to be on the next slide. So now let's talk about how this implementation is going to work. Let's start by taking a close look at the method signature. So we have public static number. So this is a method that's going to return a number. The name of the method is getLargestNumber, and as an argument it takes an array list of number called list. The first thing that happens in the implementation is we check to see if the list is empty or if the list doesn't exist at all. In other words, if it doesn't have a reference, if list equals null, that means there is no list. Or if there is a list but the size of the list is 0, then in either case there's no numbers for us to go through and compare and find the largest one, so we simply return null in this case. On the other hand, if we make it past that if statement, then it means we do have at least one number and we need to start going through the list to see if it's the biggest one. We start by assuming the biggest number is the first number. So we say number max equals list.get0. So that is our first stab at the biggest number. Then what we're going to do is go through the remaining numbers, if there are any, in the list and see if there's any that are bigger. We do that in a for loop, starting, you'll notice, with index 1, not 0, because we've already taken the element at index 0 out of the list, and that's our max. We start at the next one, element 1, and work our way through to the rest of the list by having I go from 1 to 1 less than list.size and bumping it up by 1 after each iteration. What we do within the for loop is we have an if statement that checks to see if the biggest number we've found so far is actually less than the next one. But take a closer look at how we've done this. We've actually done max.doubleValue, and the reason for that is because, remember, this list contains different types of numbers. It could have integers, it could have big integers, big decimals, bytes, and so on and so forth. And in order to do a comparison, we need to, in every case, make it the same type. So by using the conversion method double value, we're going to make it into a double value regardless of what it was, so that we can then go ahead and compare the biggest one we have so far to the next one in the list. If what we found so far is actually smaller than the next one, then we're going to go ahead and revise our record of the maximum value by saying max equals list.getI. In other words, max is now the current element that we're looking at in the list. This program actually has a small flaw in it, and that is that if we're looking at big integers and big decimals and we do a conversion to double, it could be the case that we don't actually have a correct representation of that number, because doubles are inherently going to be potentially smaller than numbers that we might be able to represent with big integer and with big decimal. So that's actually a little bit of a problem here. But in the case of the example that we looked at, it will wind up working just fine.